3453, which is used for the measuring of osmotic pressure, conductance, surface tension, and viscosity. It is a unique instrument in the world as it is measures 4 different properties using a small quantities of liquid. The instrument is approved by WIPO, World Intellectual Property Organization. His invention, the frequency and Mansing equation are globally used in the scientific community. Yes, sir, we know those who are working in the field of nanotechnology knows the importance of frequency, which is calculated with the Mansing equation. EcoBudget is invented by Sir, is used for the titration. It is user friendly and use very small quantities for the titration. Vision meter is invented by Sir as having a really noble cause, and it is enables visually impaired people to study the properties of liquid like volume, valency, and quality controls of liquid. He is actively engaged in a research and he is credited with 180 research papers in the peer-reviewed national and international journals, 8 patents. Sir has guided dozens of PhD and MPhil and master students. He has visited several countries like USA, Japan, Switzerland, Germany, Singapore, UK, Thailand, France, Australia, Nigeria, Ethiopia, Nepal, Pakistan, and Poland. Sir has been on the panel of board of central studies of the many central universities. Sir is very innovative in thinking and always motivates students for practical application of the project, which is a key point to become a successful entrepreneur. With this creative and innovative experience, I request respected Professor Mansing sir to enlighten the trainers gathering with his talk. Sir, please sir, over to you, Mansing sir.
Thank you very much for giving me an opportunity to interact with the galaxies of intellectuals. Initially, Mithali Madam, Honorable Mithali Madam, and Honorable Rajendra Deshpandeji, and other dignitaries of the event. It is my good luck to share my my work with the upcoming scientists and the well-established scientists, with the hope that this interaction could evolve and could lead to develop some new state of art. And in this regard, today's this interaction through this program could be focused on that frequency chemistry and the rheology of drug. Ultimately, the molecules which have biocompatibility, they in way or other way, they are definitely assist the life. So in that way, it becomes
डॉक्टर मानसिंह आपका म्यूट हो गया है, म्यूट अनम्यूट कीजिए डॉक्टर मानसिंह.
And also the devices which could truly explore the potential properties of the biocompatible molecule. Of course, pharmaceutical materials of pharmaceutics is one of them. So in this process, I hope that we will also try that how and when our research activities, when we are performing the research activities, or even when we are doing taking classes, interacting with the young minds of the country in the classes, that time I think it becomes very, very vibrant and very, very effective if we little bit interact and involve in the discussion. I hope that kind of discussion may lead to some new mind-boggling ideas or mind-boggling thoughts. So the word which you are seeing here, frequency, it is the outcome of the same. How almost everything is the outcome of mind-boggling activities and research. or discussion or interaction. So there is no any special minds to create and to generate, but it is only interaction and little bit visibility. If we are little bit attentive and we are little bit enthusiastic, and if are little bit curious to know and to take up the research activities or the understanding about any molecule or about any phenomena to the higher level, then truly it establishes a new milestone in the areas of pharmaceutical sciences and in the areas of nanomaterial and science, nanomaterial and nanoscience and technologies. So in this context, this I will take up the this thing. I will take up to go the next slide, that pharmacokinetics fundamentally, if it is on the monodispersion scale, then it develops a remarkable rheology. And first, I would like also to explain the terminology of the frequency. We know that when we are dispersing water, oil, there's no concept of adhesivity or no question of adhesion. However, when we add the surfactant, because of interlocuting activities of the surfactant as a hydrophilic and hydrophobic, it interacts with the cohesive energy of both the water and oil. So it means the cohesive energy, if it is converted or reduced, then it creates a new energy. That energy helps in adhesion or interaction, in the sense adhesion. So and then adhesion means then molecule start moving from one location to another location, then dispersion, then friction, and then so many other things. So frequency means it is a product of cohesive and frictional forces, and these are two fundamental properties of the drug designing or any industrial formulation, because your recipe, your ingredient has to interact with the medium and also has to adhere medium around this, so that coagulation is stopped and bulk formation is stopped, and bulk molecule may not have any kind of rheology. So rheology, I am talking that when does a molecule is having different constituent and functional groups, and these functional groups differently respond with the medium, whether it's a buffer or whether it's a something else, but it is a liquid medium. So it differently responds. When it differently responds, then it develops a different, if it is water, different hydration sphere and different surface energy, then also the different activities. In this way, when it is in the arteries or outside capillaries, then what will happen? That the molecule or the constituents may not advance with the same speed. There is a shear stress, in the sense that the molecule which is near capillary, that it may be having adherence, while the another part of the molecule might be dragged forward. So this kind of signs where that stress and strain is developed in your drug molecule. So this stress and strain developing drug molecule may not be so effective. So in context of this pharmacokinetics means distribution, effective distribution. Pharmacodynamics, okay, that is interaction and all. But this distribution, if it is monodisperse in the sense adequate surface area, adequate surface charges have an opportunity to be aligned with the medium or with the tissues or with other things, whatever in this foreign molecule or like xenobiochemicals. So in this context, this frequency is a very remarkable device where this rheology is well defined, not only well defined, but experimentally determined. So in this context, we have to see that when drug, how drug is responding to an organism, this depends on its state. As I have already explained, that drug, if millions of molecules are together, then drug is engaged in coagulation rather than interacting with the tissues, rather than interacting with the desired part of the body. So ultimately, the cohesion and adhesion, the cohesive force means the tendency within the similar molecule or the drug to be together. Then it is then distribution will be effective. And the adhesion means when it is interacting with the solvent and making the solvent is adhering around it. However, it is also very important that if there is a monodispersion adhesion of the or mono layer adhesion of the solvent around the drug, then it remains effective. And quickly, and less activation energy is also required for its distribution. However, if it is in the bulk form, then too much energy or all ATPs are utilized even in dispersing a drug and also availing its surface area. So we can say that pharmacokinetic monodispersion enables higher entropy in the sense, as I have already told you, drugs is a heterocyclic molecule, different functional groups, different atoms with different electronic activities. Since they are not uniform, means not similar, so they start oscillating, they start vibrating, they start rotating. So these different intramolecular activities or disordering or motions, that is called entropy. Entropy is outside, while this entropy is within molecule. And because molecules have remarkable various constituents with different electronic configurations means electronic activities, electrostatic activities, dipolar activities, and these ultimately lead to develop a adhesion with the your body fluid, the blood, whenever it is transported. So ultimately, molecular clubbing inhibits surface area, surface energy, and increase size. The size increase is a dangerous thing. We do not find that size should increase. So each constituent is unable to oscillate or to respond. A fricofluidics means where the cohesive adequate ratio between the cohesive and the frictional or adhesive forces. If it is a moderate ratio, then we can say that a drug is effective or rheology is moderate, and it will facilitate the drug to properly distribute with proper surface area. Similarly, this frequency chemistry, because drug is like a mass transfer, it is not localized in the mouth or wherever it is given. It has to be transported. Fundamentally, it is not like electricity, that electrons, that atoms are static, and that atoms are static, electrons are moving. The drug itself has to be transferred, or it means is a mass transfer mechanism of the bulk. It's a very costly affair, as I have told you. Mass transfer mechanism of a bulk drug, as it needs too much energy, and that could not be so desirable. And hence, this monodispersion kinetics is needed, and that is helpful. So, in this context, the frequency chemistry has become a most desired physicochemical properties, and this physicochemical properties within the scales of the better distribution, within the scales of better expression of the surface areas, within the scales of better alignment of surface areas, within the scales of better multiple nanohydration spheres, multiple nanohydration spheres, not the bulk spheres. Nanohydration sphere means their functionality is maintained. It is not high surface area. When size is less, high surface area, contrary to the this mercury. So now in this context, we have to understand, and we know that this monocompartmental model of drug, that where drug somewhere different, somewhere different, so this is not equal. So that time the concentration gradient becomes a force to equalize and to equally distribute. But of course, if this ratio monocompartmental model of the drug distribution is very much affected by the frequency. If frequency means there's no proper distribution, no proper surface area, or no proper surface charges available to interact with the binding or with the transporting material, at that time it is also not of any use. So in this context, we have to understand that the monodispersion of the drug, it is a better, it could go to any tissue, it could go to any part without creating too much stress, strain, and without creating too much concentration gradient, because concentration gradient itself is a negative factor. And this somewhere maximum concentration, somewhere least concentration. So kind of a potential jerk or potential shocks, chemical potential shocks. So we have also to avoid these potential shocks. Now, this is the overall fundamental distribution kinetics, where if you see this here, initially distribution and then almost steady state and then release dynamics. So ultimately this area under curve AUC decides the yes, it is distributed this way and it is coming back. It is no haphazard. There's a proper distribution, Gaussian on the Gaussian pattern. When it is being administered, then after that it is start distribution, not in a whole molecule, but kind of a degeneration scale. Degeneration scale means 1:1, 1:1, molecule by molecule. It is going to tissue, and there's no much stress and strain on the tissue, and drug is also easily transported. And after it's whatever mechanism is there, and whether it is utilized or it is excreted, that way is also monodispersion. If it is stronger, surface charge is not moderate, and that time excretion could also be a difficulty. So now we have seen a molecule, a kind of a we can say a dendrimer, or it could be surfactant or web dreamer, web-like structure, because it has cavities, and when it is moving, it's branching at the core. It is a dendrimer at the core, and these are the cavities. So this is a perfect example of shear stress, because its lower part is somewhere attached to the blood capillary surface, blood capillary surfaces, but upper part, which is almost open, it is trying to be dragged out. So this molecule is coming under stress strain. This is the fundamental science of the rheology, rheological stress and strain. So this molecule could rotate and could also translate, could vibrate. So if it is a monodispersion, then in this cavity, a very desired a smaller optimum amount of the drug could go ahead, and in this this molecule drug carrier could bear these rheological defects, and so these rheological defects may not affect the real drug. So that this is the fundamental that fundamental molecular economy of a drug transport or drug carrier mechanism. So this in many activities like antioxidants, because we know that antioxidants, they are also like a drug. So this molecule is having this is cavities, and these cavities are the nanocavities, not like a that bulk cavities. So only few molecules distributed, partitioning. When it is a partitioning, then they maintain the larger surface area of the drug. Similarly, we have seen here the polyphenols, antioxidants, and we found that a drug stability and drug release is also sustainable. If it is a drug is a partitioned in its cavities, not in a bulk form, but in a moderate population, then release is also a very sustainable, not a burst release. So we have found that certain drugs, or if here we have studied the polyphenols. So polyphenols, when they were also centered, so their antioxidant activities on the this DPPH free radical, it was so moderate with this dendimer. It is a dendimer, very slow and first order, not a stress and strain. So now another important point, when we have this slide is a very fundamental and very basic slide. So we have taken water, aqueous leaf of guava extract, and aqueous ZnCl2, aqueous polyphenol capped ZNO nanoparticle, aqueous DMSO, and dendimer, dendimer, and trimethyl, tri-di, methyl malonate dendimer, and it is in aqueous DMSO, and then capped in this dendimer, and this capped ZNO and nanocluster. So we have seen that since this partitioning is maximum, so shear is maximum. When it is maximum, before partitioning of drug into its cavities, it was together. So when it was together, then it was having stronger cohesive forces. So if you see the right hand side figure, the stronger surface energy or surface tension. But when it is higher, then surface energy is lower. So increase in the shear stress or viscosity, decrease in the surface energy or surface tension in for a mutual coefficient as viscosity. This fundamental science, where two forces are basically making drug economy useful, means partitioning drug and making drug to act in a very effective way. So there it means viscosity chemistry. When we have studied this and this fluid dynamics model, and in this fluid dynamics drug, it's basically in the arteries covered in the fluid dynamics model. So it could be a very excellent startup. The application of the service meter. Service meter is the only device in the world which together measures these fundamental parameters. It measures the shear stress or viscosity at the same time within the same system, same sensor, no change, no experimental condition change, no any pH change, no transfer of sample here and there. So this is a fundamental startup of the drug designing, that these two forces vis-a-vis cavity partitioning in dendimer, rhabdimer, or some other drug carrier. It could be a very fabulous operator. This viscosity is a very remarkable and fabulous operator. It directly, accurately predicts the state of the drug, that in what way it is distributed, whether it is coagulated or whether it is uniformly distributed. So it is a very effective science. Now, in the same way that disinfectants also, if it is higher energy, then wettability may not be there. So like Savalone and others, it is made up of quartz. Quartz means the quaternary ammonium salt, quartz, like cetyl, citrimide, alkyl, trimethyl ammonium bromide, 2,3 are mixed. And this chlorohexidine gluconate. Similarly, we can also develop our own formulations. We have in fact developed more effective than this Savalone, or this initially it was cetavalone. We have taken the dendimer, and we have taken the ionic liquids and certain surfactants, and we have added a very useful and remarkable functional web dreamer, that has acted as an excellent uh, disinfectant with highest washability. So this is another startup of the service meter, because both parameters mutually go hand in hand, and there is no any other device. It is a simple device, only direct parameter measurement. So this distribution we already know. This is a simple device where sample filling and data measurements and its certain parts and reflection within different parts. And if mutual solubility of drug can be also studied with, if you see here, right hand side, IFC, interfacial interfacial capillary, or interfacial this IFT, interfacial tension. This drop is coming. If this drop has, you want to leach, study the leaching one medium to another, you can take that in this medium, and then you can study whether truly drug is being leached out, is being distributed or not. So it is another fundamental, remarkable that startup of the service meter, where leaching or preferential activities of the drug within the solvent could be easily studied. This is simple overall all units, so different units, VB, viscosity, buffer bulb, and mark reference point number 4, different things. And this is the fundamentally CPU, control pressure unit, and surface tension, this bulb and viscosity bulb, and this buffer bulb, basically viscosity buffer bulb and surface tension buffer bulb. And this is the major limb where sample is taken, and RB reservoir bulb, and this is a zero energy band where even if you transfer the sample, there is no shocking at all. And PDN, see here, pendant drop number, sample first is here, then it is shifted to this unit, then to this unit, then different units. You will surprise that it is not, no sample is in contact of air, and hence the drugs which get easily oxidized or reduced in the open environment, or absorb moisture or something else, or interact with the photons, that is very safe. That's because sample does not come outside when you are measuring, only transferring from this to this. So this is a very unique parameter, the device which fundamentally measures the very critical parameters which are responsible for drug design, distribution, and its generating the adequate surface area. This is simple. We know very well that drug distribution, and ultimately this we already know that passive, because of concentration, because of this thing, it means through protein or through binder, if it is not able to properly interact with the binder, then has means adhesion, then nothing will happen. And hence in this respect, frequency is a fundamental monodispersion parameter in both the cases, because protein or carrier, this is has to interact or adhesion with the drug. So in this context, now it is a very if your drug is of different size, ellipsoid, spherical, or something else, what happens to the rheology and how it is affected in the blood itself. So if you see that ellipsoid, this is slightly more viscous. And why it is more viscous? It seems that somewhere these ellipsoidal structures, or they come closer, and when they come closer outside their surface, also larger medium adhesion. So therefore its shear stress is maximum, shear rate is reduced, and similarly when it means its transport will slightly take time. And similarly, when you are taking any drug of spherical size, that time its a shear stress is less. It is before you. So this is a fundamental science that drug shape, dimension is directly connected to its mass transfer in the body. Now, similarly, when drug is given to the body, that time it may undergo a pulsative state, distribution state, or non-Newtonian state. And similarly, it could be static with time. It may not go forward. It may be steady wherever it is kept. Or if it is also in the oscillatory mechanism. This is a very, very remarkable startup of this service meter, because these two, three things are only, such studies are only possible when the cohesive and frictional forces are fairly studied and also tuned and engineered. So if you see the zeta potential, the highest zeta potential, the shear stress is higher. And if it is a medium zeta potential, and you know very well that zeta potential is directly connected to the surface charges. And if surface charge is directly connected to the, therefore everything is connected. So this model is a non-Newtonian in the sense that in situ, when drug is inside, it is undergoing certain structural changes. So rather than interacting with your tissue, with your desired part, it is involving its own activities like pulsative, oscillating. These are the expressions of energy with time. So with time means non-Newtonian. It is not same. Drug is not in the same structural state. It is in different structural state, and hence the charges and overall rheological picture it changed. So we have again see the spherical charges in this case bulk. When it is bulk, see the bulk means it is the maximum cohesive forces and no distribution. While if it is here maximum polydisperse, when it is monodisperse, right hand side you can see the maximum or moderate shear stress. It means it is able to interact adequately with the circulatory medium and it can go. So this is another startup of the service meter. Such studies could be adequately conducted with this service meter, single device. And I told you viscosity or surface tension both should not be seen in isolation. They are the mutual function of each other. So this here is seen here, as I told you, least this on lower viscosity or shear and higher cohesive force. So if you reduce the cohesive force, you can get such sign. Similarly, the concentration sensitivity of the drug. Small particles, they concentration wise with time, they are more sensitive because surface area more. Surface charges are exposed to interact with time or with concentration. So this slide highlight the same. This is C starting, but if it is large size, then almost equal with time or with concentration. So such a drug is a kind of not very much active. You want some active drug which could immediately start interacting. So you have to maintain the cohesivity or the surface forces or surface area. And entropy, that is a fundamental property of the entropy, because all constituents, they have their electronic structure, electronic configuration. They will independently start acting when it is monodispersed. Same thing is here. Non-Newtonian means it changes with time. So now if you see this picture, it is low zeta potential coagulation. When it is agglomeration, see this faster change, quick or collapsing in this. So I may getting together. So such a collapsing system is not required to the body. There should be some first order kinetics of that pharmacokinetic. First order. If it is multi-order, we do not know what will happen to transitional state. So same thing that ultimately we can say that this 4 signs of frequency is cohesive force of molecules, and ionic hydrations are also like electrolyte. When you take electrolyte, that time what happens? The Na and Cl, they are dissociated and they further structure the solvent or water. So such situation could be also avoided because zeta potential is a little bit create trouble there, and multi or layer water molecules, because these are direct cation and anion. So better to have the nanoemulsion by using the the surfactants, any maybe cationic, anionic, or any. This is a fundamental model before you start. When the shear, if it is disturbed, then the shear is going out of order here and there. Such system of the drug, rather than benefit, providing relief to the body or tissue, it is taking its own mechanism. So such taking own mechanism, rather than like interacting with you, I start with myself in this lecture. So I will not be able to deliver. So if I want to deliver truly, I have to concentrate on the track. So drugs should have a mechanism where it should not develop any transitional mechanism or transitional activities. So similarly, this also this chemisorption or physisorption, they should also be physisorption scale is excellent. Why? Because if stronger van der Waals forces or residual forces are developed, that time the release of drug may not be possible. So better to maintain the physisorption. This is a remarkable startup and of the service meter, because volume and entropy both are very very critical parameters in this case. So entropy, when it is monodispersed and moderate van der Waals surfaces on the surface, that time there is no possibility of chemisorption. It should be physisorption. So similarly, not only drugs, if you want to develop a photocatalytic thin film or conducting thin film, heat conducting, electricity conducting, that or cosmetics, that time also monodispersion or this frequency chemistry is a very remarkable startup. Maybe cosmetics, we know that nail polish, if this is not properly dye, is not monodispersed, then what will happen? The photon will, if it is multi-layers, the photon will come and will be absorbed by another layer. The localized heat generation, crack theory starts, and then ultimately today or tomorrow on that skin where photons are being absorbed, some disease will start. However, if it is monodispersed, then no chance of absorption of photon. Photon comes and reflected. So this such mechanism of monodispersion is very very excellent and useful. Same thing. This quantum, this your water medium, these like yes, solvent also triggers a very remarkable science for your drug. So it is written that frequency extraordinary determines ultra intrafacial science of a molecule loaded with sample of nanoemulsion as 2D layers in laminar flow. Such sciences fully aligned without frictional or opposing forces and accept self-designed open. So it means that we have also to take care of the medium or the solvent. It should also be in a way that it should not develop a chemisorption type or permanent bond. It should be dispersion. It should not be a reactive mode. So we have to understand this intrafacial science of two molecules. That is really a very remarkable molecular economy. Otherwise, your whole drug will be as such in the bulk form and will not be of any use. It is not able to develop a remarkable intrafacial science with your tissue, with your part, which is where it was required, because it was engaged in self mode. So such kind of molecular economy is of no use. Therefore, service meter also tracks these activities. You already know that this larger side top to this top means the higher cohesive and no adhesion. Such devices of no use. And similarly, because this surface plasmonic resonance, I have already and photocatalytic activities. I have already explained that if it is a monodispersion, then frequency is higher, then surface is very effective. And we have studied this nanoemulsion, microemulsion. When it is too much, it starts coagulating. So such material are reaching to microemulsion of no use. Capped means polyphenol are capped with nanoparticles. And this is the another which we have conducted and developed this polyphenols capped means polyphenol capped nanoparticle within the dendrimer in cavities. So this dendrimer also reorients the functional groups of the drug, whichever are required for curing. So this is another fundamental science of this a dendrimer, that it is orienting also the drugs. This its geometry, and it's a surface studies. You know, this is if residual surface charge if equal, then it is excellent. If positive more or negative more, then definitely this will be accordingly. It will create the that activities, chemical activities. Now, same thing here. This is your H2SO4 and H3SO4 on this pattern. Now we have seen that H2SO4 size is more than the H3PO4. Why? Because this side negative O surface charges adhering large number of water because there is no any repulsion from any side. While here O minus O minus O minus. This is shorter side because at least least number of water molecules are adhered to this. So that's why surface charges are very effective, and they work a lot. It is simple. Bringing this on monodispersion, see the properties, reflecting properties, interacting properties, and surface properties of oil when it was nanometer dispersed. And it is simple organic sanitizer when natural molecules from fruits, peels, and others, they were prepared, remarkable, washing, cleaning, everything, just natural. Because this ionic sanitizer, when you take NaOCl, it is corrosive. And when you take 70%, it is dehydrating, completely trouble. And this quantized organic sanitizer, which we have developed, a very remarkable highest surface monodispersion surface area, which is studied with the service meter, another startup. Same thing is here. It starts molecular temperature. This is nanoemulsion which we have prepared because the antioxidants or any drug, if it was not soluble, antioxidants, quercetin and others we have taken, they were not soluble in pure water. So we have taken 1%, 2%, 3% DMSO. So they did not disperse up to 9.9%, 9.8%. So when we have gone to 10% disperse, they see the properties, nanoemulsion, transparent. And this is the property when it is oil is together and when it is monodispersed, fundamental capability to respond to the light. Otherwise, it have good absorbing. So same thing as I quoted nail polish and sim monodispersion, compatibility for farmers, remarkable. Farmers are using pesticides and they do not know the proper formulation. If their pesticide monodispersed, then their remarkable pesticide economy and molecular economy of the this thing, because a small amount is spread in larger surface area of the crop or leaves. But if it is a very stronger cohesive force, see that adhesion. They are just a larger size, surface area is not covered. So this is the another remarkable this startup of the wettability study with the service meter. This is the only device where eta means viscosity, H column rise in the capillary, the time T and gamma. These parameters are only determined together, mutually together with service meter. There is no any other device which can measure this because it is having all these multiple sensors. So this is the fundamental economy, molecular economy, pesticide economy, and also truly pollutants are not going. Otherwise, unnecessary. Farmer is also purchasing large amount of pesticide and just throwing and just storing in the on the leaf or in ultimately go to the land. So that similarly urea also. So see the economy like this and microfluidics. It is a very remarkable science, microfluidics. If it is monodispersed, it can enter the capillaries and uniformly, no hurdle, no any transitional state intra and no any engagement. We have seen in nature it is already there. We have conducted this experiment. We have taken this orange peel and connected this because it is, if it is continuity, if it is not right, then only you can determine. And we found that circuit was complete because this current was flown in milliampere. So this microfluidics is studied once you very well know the cohesive and frictional forces or least cohesive forces and monodispersion. See the same example. Now we were surprised to see this experiment with pepsin. This pepsin was dissolved in the water. It was just not properly dispersed. And when it was magnetic field was given 2.5 from outside, magnetorheological fluid, it was see that unfolding or confirmatory state. But when we have added 0.005 gram FeCl3, where the electron 5 electron 3D in one direction, see the unfolding. So we have measured this, that yes, protein is unfolded to desired state, and we have determined unfolded surface area increased. So see the continuously surface area increase, and it is another remarkable startup of the service meter, that proteins are either the chemical unfolded, denatured, or by thermal, or by mechanic. But here, without touching anything, just fitting the shoe magnet in a quadrupolar, negative north south, north south, quadrupolar, 4-pole, 2 magnets, shoe magnet in a quadrupolar form. And see, BSA confirmatory state from this to this magnetic field, a confirm state in no change. It means this is a protein confirmatory state which is stable. Sometimes are looking to develop a remarkable unfolding to the desired confirmatory state. So service meter, by using the magnetic shoe magnet of desired Tesla, magnetic field Tesla, that time you can determine the distinguish. So air BSA, see initially faster changes, and so more here shear is fixed. Faster shear maybe because of tryptophan or tyrosine, because that has BSA, or maybe alpha sheet to this convolution, maybe alpha sheet to beta sheet convolution. So, and see this as albumin, almost no too much change. So you can easily understand that sometimes what happens when we give magnetic therapy, this system can also study that your protein can tolerate this much magnetic field. If you are giving too much magnetic field in magnetotherapy, no use. So it is a very wonderful, remarkable startup of the service meter through this magnetorheological properties. Now, another important point, ionic liquids, these are very important. Ethyl, 1-ethyl, 3-methyl, imidazolium chloride, 1-butyl, 1-hexyl, and we have studied this in citric acid, water citric acid, and citric acid hemoglobin, and then we have added these ionic lipids. The structure is seen, and we have determined this. It's only viscosity. See, when we have changed water citric acid and hemoglobin and then ionic liquids, there is no much difference. So when we have measured the viscosity, because here only one force, that is frictional, but when we have measured the viscosity, which is the product of two forces, this is Mansingh equation, written with Mansingh equation. There are clear cut indications कि yes, up to this extent, citric acid solution, aqueous citric acid solution exists. From this to this, then hemoglobin, and from clear cut partitioning. So such a device, remarkable, fundamental. Similarly, you can also extend it to the drug. So of course, this hemoglobin is a protein and biocompatible. And when see this increasing that alkyl chain of ionic liquids are, then it is linearly going, because because same structure is only except alkyl chain. So now this is another important aqua gel for anti-wrinkle nasobial biofluid. It is a fundamental thing. When we see the KCl, see that it's an electronic configuration, 8 plus minus this K, 8 electron. We add it in the gels, and because there is no much ionic hydration of similar thing, unequal molecular force distributions localized. That's why nasobial, nasolabial, this laugh lines or wrinkles are developed. But when it is added in your gel, aloe vera gel or some gel, because these two cation and anion, they develop the simple ionic hydration of same size with same positive one, negative one. That's why it does not allow any localization of the unequal forces, and your wrinkles could go away. So this is a very fundamental. Similarly, if you are taking any drug, you are trying to see in which it is more soluble, whether it is a sodium nitrate, sodium chloride, or sodium acetate. See this here, frequency. So sodium nitrate we found it is more solubilizing because higher frequency, and NaC, sodium nitrate is not allowing because of stronger, exceptionally stronger ionic hydration, and it is moderate hydrophilicity also. So this is a very fundamental. Similarly, we have also tried to study the curcumin loaded formulation on antioxidants with graphene. Graphene is a very useful science these days. So if you have a look on this table, when graphene was added, this free radical conversion, see this studied with this 97.5. When only this curcumin, then anti that oxidant scavenging is very least. So this and now this is the overall mechanism where this the curcumin is attached around this, and monodispersion same thing. Free radical is also connected. This is a fundamental unique graph that free FRSA means free radical scavenging activities of assisted by the geo means graphene oxide. Here we are looking that this is slightly frequency is slightly less, and FR is more. It shows that moderate because it is somewhere bringing the this antioxidants on the workable level where the free radical could easily be scavenged. So that is the fundamental science, and this is the overall graphene photocatalytic activities. And this slide, if you have a look, right hand side, it is a very remarkable. It's a really atom economy because carbon atom sheet is 1:1. So such arrangement is only made by when there is a least cohesive forces, and this another a nano emulsor where curcumin and ethanol, glycerol, water in general, thermodynamic and kinetic stability at the temperature, fixed temperature remains a question. But here, when temperature was increased, then its thermodynamic stability, kinetic stability, and entropic stability decreased because we have seen that water was not strongly suspended, not strongly bound. And when temperature was there, more kinetic energy, more oscillations, more rotational motion, all molecular motions, it came out. When it came out, it makes coagulation. Coagulation means higher surface. So similarly, this can also, if you take a reverse micelle and take separate metallic nanoparticle, uh, uh, calcium oxide, magnesium oxide, nickel oxide, then it can study, it can distinguish, or can even collect the preferential rate of these magnetic nanoparticles deposition in the center. Similarly, if it is another remarkable drug frequency model, where this methyl phenyl methane amine tetrachloroplatinate of tetrachloroplatinum, we are changing its position ortho meta para. When we have gone to para position, we have seen that intercalation of the DNA smarter. We have seen that Cl, it is somewhere optimizing the structure electronic charges also, and it is able to interact with the base pairs of the DNA. And we have seen that this viscosity initially at this concentration of this molecule, see it is higher and surface tension lower. This start coming down and surface energy start going up, or this so it means now here if we see this at this point when viscous surface tension is least, then viscosity becomes higher because this is the, as I have already told, cohesive forces When weakened, then they are allowing the adhesion or more and more dispersion. So that has become a very important in case of DNA. It is another fundamental science where not only under natural spontaneity and magnetic field, but electric field, thermal field, and laser field. So this device is patented with the European this patent office, German, France, and UK, in 3 countries. So this device is its patent is granted, and of course it is going. I also invite whosoever is interested to take this patent, most welcome. So now, this similarly the cerium nanoparticles we have studied with water, PBS, and media, and we have found see the frequency. This frequency with media is maximum because many ingredients are there and they are engaging the medium effectively, and hence this frequency are excellent material. And this trimethyl tridimethyl malonate series, the methyl, ethyl, and pentyl, and this butyl and hexyl. We have seen, see the surface partitioning. The beauty of this drug carriers is the surface is being partitioned in a more and more amount. So we have seen that when surface is partitioned, it means see the cohesivity is decreased. So we have found comparatively the least cohesivity for the dendrimer when it is having the alkyl chain of 6 carbons, and but viscosity in the same ratio, see it is higher. TTD and malonate, this is higher. This proves that partitioning of surface energy is inviting many multiple nanohydrations. So more activity, neither coagulation, nor any other thing. So in that way, such drug that vehicles are very remarkable. And similarly, if you see here, TT, no drug blast, that explosion, that bursting release. While in when this methyl, see it is a all release here, but after that gone completely. But it is sustainable drug release. So we have seen here this studies. This is also studied with frequency because we have seen when drugs are optically active, when drugs are very sensitive to UV light and all, that time transitions occur. So that time service meter is the only remedy and frequency is the only remedy. So this is the fluid dynamics, and this is the service meter ultimately, which is in the Borosill catalog, and it is going in the market like a hot cake because it supersedes this Brookfield viscometer. That is only viscometer, only one parameter, measures multiple. And Canon viscometer, Lauda tensiometer, German, and Kebron tensiometer, Finland, and Kyowa tensiometer, Japan. No, nothing is against, no comparison of those with this. It's truly a device which is measuring the multiple physicochemical and functional and directly relevant parameters which are connected to the drug design and the pharmacokinetics. So, and this is, it is going, the many centers are coming up, analytical centers using, it is in Maharashtra somewhere. I do not exactly remember, but it is in Maharashtra somewhere. They are using it as a testing center. Samples come and they have also given, they hired certain people and they are getting salary out of its sample analysis charges. And this simple sample is kept and it's a simple device. And see, these are the parameters: surface tension, highest accuracy, highest resolution, and interfacial tension, wetting coefficient, surface area, viscosity, activation energy, frequency, molecular interacting efficiency, surface tension and viscosity study of volatile, inflammable, and carcinogenic samples. In general, it is not possible. And inflammable. So solvent binding, size micelles, reverse micelles, and Newtonian liquid, non-Newtonian liquid, ionic liquids. So all these are studied. This is a fundamental science where the multifunctional sites, if we have a look, and this molecule fundamentally has given birth to the frequacity. When we have measured its viscosity, we found that at a specific concentration, or it is failed to resolve the stoichiometry driven activities. See the dark areas. So stoichiometry is there, but the active mechanism is not, we are not in position to resolve its mechanism. While when frequacity was measured accidentally, it was an accidentally, because big things are come through accident. For planning, you can make a building. By planning, you can purchase a big car. By planning, you can purchase a good tie. By planning, you can have a good dress. But inventions, they come by madness. So this madness experiment, this frequacity, see, no area is resolved. It authenticates yes, frequacity, which is a dual force theory, that it accurately resolved the stoichiometry driven sciences or mechanism. So this is a very fundamental science. This is the Mansing equation to determine this frequacity. This is a T is the viscous flow time for sample, and T0 for medium. B by T, this kinetic energy correction, because if molecule is bulk and transitions, then this parameter becomes very unique. So you want minimum. If your system is perfectly not creating any shock, that's why I have shown there zero band energy. And N is the band and drop number of the sample and of the medium, and this is the buoyancy factor. And we have found that service meter such an ultra accurate device. So these two parameters, 10 to power minus 7 or 10 to power minus 6 omitted, and we convert this equation is further modified this after removing these parameters T by T0, and further these solvent medium parameters are taken out, and this parameter becomes a constant because frequacity of the medium, T0 of the medium, N0 of the medium, and functional concentration dependent parameters T and N. So sigma by 0 by T0 or N0, this is the MC, Mansing constant. If you put it directly proportional. So this equation, if you also derive this Mansing equation, derivation wise, it is ultra accurate and be highly economic. This frequacity economy, because no density is in this term. So we do not have to purchase the density meter, and we have not to use measure. Many see in measurement, procurement for density meter, infrastructure, electricity, manpower, so many things are deleted by this frequacity noble breakthrough on this Indian soil. Now this is, as I have already told you, that leaching of the drug from preferential leaching of preferential solubility of drug from one medium to another medium, that is possible by this service meter. And this can also determine if your drug has conjugation or non-conjugation, whether conjugation is effective or not. This experiment shows that conjugation of your drug is not much effective. This interfacial tension of the benzene 14.32 higher, it means it is when water benzene was there, it means it was not too much allowing compatibility at the interfacial tension. But when you have taken cyclohexane, see 10.59, or if you take this for one pi conjugation, it was for 3. So for 1 pi conjugation, 1.2 millinewton per meter contribution. So additional this much energy is required if your drug is having pi conjugation. This is a clear-cut accidental experiment. Now, same thing if you are really interested, whether you take isopropyl alcohol or some other alcohol, trying to disperse your drug and taking ammonium acetate or so. So this experiments of service meter, interfacial tension measurement, mutual solubility of your sample shows that when you are taking sodium acetate, please, your drug will not be mutually solubilized. Don't take such. Take ammonium type system, because ammonia 4 sides of hydrogen bonding. Sodium, no. So it is better to decide your solvent or medium by such a fundamental intrafacial mechanism, because your drug and solvent, they develop a functional interface. So this experiment explains the same thing. And this experiment, uh, we can extend it to so many drug designing, whether truly the drug will be only one phase or phase extraction possible, phase extraction whether in a burst manner or phase extraction in a controlled manner. So that also very important. We know that many times the salts, alcohol, water, many other things, they are used to develop the formulations for drug dispersion. And see, this is another very that groundbreaking experiment, that this iron nanoparticle, water, and this saline, iron albumin. And if you see this thing, this experiment, it is a concentration and it is a frequency. We have seen iron oxide means with titanium. We have seen that titanium oxide has developed with egg albumin, has developed maximum dispersion or highest frequency, and it has allowed maximum percolation, maximum dispersion. And the egg, when egg was there, from the top where gap is there, this solution was transferred. Since I have been telling that monodispersion, so only titanium of a small amount, maybe 10, the 10 to 50 microgram and only 20 nanometer size, it has been successfully percolated to the embryo, which was responsible to develop the full-fledged this chicken. So this chicken, and now this is completely destroyed because that is interacting titanium oxide nanoparticle. It could not develop the proper growth of the this chicken embryo. So it is a very excellent experiment and significance of frequency. This paper is already in Nature, that is scientific report. So ultimately, I could conclude that sometimes we have to be out of the box. Sometimes we have to be abnormal. Sometimes we have to be mad. Sometimes we have to be mental. Sometimes we have to crack. And if we are very civilized people, then routine following route and putting proper uniform routinely, taking lunch, dinner, breakfast, everything routinely, our thinking become routinely, and then I do not know what will happen in the future. So we have to be little bit mad, we have to be little bit mental, we have to be little bit out of the box thinking, and I do not know whether planning somewhere is making anyone to be able to generate the remarkable breakthroughs or the unplanned accidental things. You know very well that I want to share one story of the soap that near the near the Italy, there is a one this mountain mountain Sapo. They started this uh, this burning this offering to the god, and it was Sapo means Sapo mountain, and they took the animals, they tied up with the pole, and they from the bottom they started burning slowly and slowly, and blood everything started coming down. When it started coming down, they thought animal is crying, material is coming. They thought now God is happy, God is happy, God is happy. But the fat and other things, they went to the nearby pond. When they went to the nearby pond, the people who were washing the clothes, and this soap pond, so means fatty acid, salt was already there. Then soap was developed, and sapo has come from soap has come from sapo itself. So then shining, the clothes were washed in a nice way. So then when it was analyzed, people started working. Some people say that soap is Egypt and all, but this is the fundamental original that invention, breakthrough of soap invention from Sapo Mountain, Italy. And and the people, the all intellectual galaxies who are participating, organizing, they are highly intellectual galaxies. Like them, they started analyze. When they started analyze, then they found that it is the something material, carboxylic and sodium. Then something is developed. It means let us give a name sapo, soap, sapo. Soap has come from sapo. So I do not know whether we will be bapo or tapo. I do not know. So sometimes we have to understand, and we have not to go in the repeated, repeat, functional group change or this change. Let us make them breakthrough. No problem whether it comes or not. It is immaterial. So I can say that nano drug material cohesion, adhesion are mutually worked, and they are fundamentally defined functionality, efficiency, pharmacodynamics. First, it is pharmacokinetics. Then only you can go to the pharmacodynamics. If drug is not properly reaching there with proper surface area, proper surface charges, the whole story which I have narrated may take over. So nano drug materials, cohesion and adhesion mutually work together. And you will surprise that cohesivity means fric from the frictional force. Cohesive means cohesion. So this frictional remarkable interface. I am not saying that have given this, but definitely it is a breakthrough. It is a remarkable breakthrough, mathematically proven and experimentally proven, and also analytically proven, mechanistically proven, and it is patented technology. So why to go for viscous, and why to go for this adhesion? Directly go to the frequency. This whole lecture probably leads us in the same direction. I'm not saying that I have this is I and no meaning. We will one day die. It is the national things. Everyone will die. So we can say that many authentic studies in frequency as a functional operator for nanocolloids, nanoemulsions, capping, coating, and so many others. Is a remarkable science, because capping, and it is an biggest asset breakthrough for nanoscience and technology. So I can say that this alone cohesion or alone adhesion has no existence, no meaning. You can do, people have been doing, I am not saying, but why we should not unearth the potential science, a potential parameter which is has never been explored. So frequency does the same thing. And nanoparticles have higher surface area with the least activation energy, tend to interact with self or cohesion. It means, so what to do? So ultimately capping, monodispersion. Then only your drug will not be coagulated, will not be coalesced, will not be sedimented on pattern. We see that medicinal syrups, if it is, they are not properly thermodynamically, kinetically, tentopically means their constitutional electronic activities in the single molecule. There are many constituents which have their own electronic configuration, own electron configuration, electron sharing or electron repulsion or lone pair electron or shared pair electron. They generate remarkable properties in your drug. And if they are tuned by frequency and service meter, it will be a wonderful science and remarkable that startup. So, or with medium or capping, coating, these are adhesions. Adhesion means the two different molecules. Your drug either with the medium or with the buffer or with other things. So it means your main drug is not cohesive. So, and it should be adhesion means mono adhesion, not a multi-layer. I quoted the example of sodium chloride. I do not know why when we take warm water, because we weaken the cohesive force and we increase the kinetic energy, like a Schrodinger equation, potential energy and kinetic energy. So cohesive force is the potential energy and the adhesion is the kinetic energy. So both energies mutually work. Then only Schrodinger have become successful to give a new breakthrough, Schrodinger equation for electron and proton behavior overall. Similarly, the frequency is also competing, not only competing, it's creating a remarkable, not competing the vacuum or filling the vacuum, but it is making a new breakthrough, which is far better than the Schrodinger electrons are automatically part of this frequency. So no quantitative parameter and device to measure their mutual activities exist yet except frequency. And measurement, not only concept. As I have told you, I have shown the accidental figure which we have drawn. We conducted the experiment in the lab. So frequency is the index of cohesion and adhesion in drug formulation chemistry, fundamentally nanoscience and drug. Mansing equation calculates frequency compatibility. It's also very remarkable breakthrough. I have also shown you the complete the, the derivation and also the parameters which could affect the value of the or magnitude of the frequency. So this science seems to be a very remarkable. It supersedes all the sciences. That's why this service meter, Borosil quickly was so pleased to commercialize this service meter in 2010. And I appreciate that I do not know all DRDO labs. It is going globally. And service meter measures cohesion, adhesion as a frequency index through the pendant drop number and viscous flow type. Two fundamental mutual parameters. Mutual faith. My friendship is with someone. If it is a mutual faith, and if it is isolation, no phenomena, no drug. No, a drug has to initiate the dialogue with the medium, with your circulatory system. If it is not initiating dialogue with drug itself and formulate and developing the bulk formation, such formulation, I think not desired. So this frequency and service meter both gives you the clear picture, illustrates the yes, drug is going in this direction. So this becomes a very fundamental and authentic science. So drugs are active molecules and need frequency control to keep them monodispersed with higher frequency, having higher surface area and least activation energy. If someone is already weak and you are giving bulk drug and it takes your whole energy rather than some energy it is giving, that's why we give glucose. So such drug formulation, I think may be avoided. So suitable for their pharmacokinetics and pharmacodynamics. So this is the fundamental technology transfer document with the Borosil. And this is another, if someone of you could come forward. This is the device which was covered by Lok Sabha TV. A documentary on this was covered. It's the vision, Mansing vision meter. You know very well when drug is having the electronic structure, every molecule having electronic structure, it is converted. We see this cell, the electrons are going from one atom to another. It means all material, water having electron. So chemical energy is converted into electrical energy, and electrical energy is converted into the sound energy. And these visually challenged people, they recognize that science. If you take pure water, one frequency, one science, that this lambda. But when you add NaCl, KCl, and lithium, then because size of the cation is different, then different frequency will be generated. So these visually challenged people do the quality control, and our Central University of Gujarat has started 6 months course for them. So successful. They are rare. These visually challenged people are real scientists. I request all of you, if you know someone, it is a free. We give free hostel, free food, and only 100 rupee charge for 6 months course. So if you know anyone, we will be so happy. Please to welcome your recommendations. So with this, Honorable Madam Rajendra Deshpande, my friend, philosopher and guide, my godfather Rajendra ji, and you have recommended myself, though I do not deserve for such recommendations, but you have recommended myself. I am so obliged of you, and Honorable Madam Mitali Madam, your greatness that you have given me golden opportunity, and with all the participants, I will be very happy if some interaction, some query questions are, come forward. Thank you very much for really this wonderful opportunity to me. Thank you. Have a nice time.
Thank you, sir. Thank you. Thanks a lot for such a detailed presentation, technical presentation. It is really magnificent to use the fundamental properties like surface energy and viscosities and their relationship in the service meter design. Sir, you have explained very well about the concept of frequosity, dendrimer cavity encapsulation. Sir showed how frequosity and it is an important parameter in drug distribution, and also suggested the cohesive and frictional forces consideration in drug design with reference to the drug structural changes with different conditions. Sir also explained about the use of service meter and its properties with so many practical example in his presentation. Thank you, sir, for such a elaborative talk. Thank you, sir. Thank you so much for detailed description on frequosity and Mansing equation, which is really helpful. Sir showed how academic researcher can become a successful entrepreneur with the patent and technology transfer to industry. Thank you, sir. Thank you. Thanks a lot. Now the session is open for the question answer. If any participant having any question, you can directly unmute yourself and ask the question to sir, or you can post in a chat box.
Sir, we are very much thankful to you. It was really a wonderful presentation, and it was a wonderful application of the basic fundamental properties in the service meter. And it is really an eye-opener for all the researchers that such type of practical applications can be done. And I congratulate you for these patents. Thank you so much, sir. The session is now open for questions.
Thank you. This is Rajendra Deshpande. I want to appreciate Dr. Mansing's presentation. Thank you very much. I have not recommended you, sir. Please, you are such a highly talented wealth of India, and it is our honor. I belong to Nagpur. I belong to pharmacy departments of Nagpur, and it is an honor for me to have you amidst all these academicians and professors of Nagpur College, Pharmacy College, and it is an honor to have you here with us, Dr. Mansing. Thank you all the organizers for accepting and being open to receive and to listen to such innovators of the country. And it is an honor to have you here, sir. Thank you, everybody. Thank you.
Dear participants, if you have any questions, you can ask in the chat box, or you can unmute yourself and ask, sir.
Sir, I have one question.
Sir.
Sir, you suggested that dendrimer can be efficiently used for the drug delivery system. So my question is that whether we need to formulate dendrimer first and then incorporate the drug, or we can formulate dendrimer generations like G1, G2, G3 and incorporate drugs simultaneously in that generations.
The dendrimer, sir. That
yes.
You are talking about dendrimer, sir.
Yes, sir. Dendrimer.
The first that generation, second generation, third generation, sir.
Yes, sir. That my
excellent,
question.
Sir.
My question is.
Yes.
My question is that whether we need to synthesize dendrimer first, like generation wise, and reach to the final dendrimer formulation, and then incorporate the drug into the dendrimer, or
okay, right, sir. Sir, excellent.
Okay.
Sir, first excellent question, sir. Because it is an encapsulating agent, so ultimately
yes.
we have to separately synthesize the core.
Okay,
we
sir.
have to select a core, and we have to select the suitable branching of the suitable charges and the length and the functional groups. I have shown 2-3 type web dreamers. I have used not dendrimer, web dreamers. Why web dreamers?
Yes.
You see the web of this spider web. There was a question from the referee that why in my that paper why you are using web. I told den dimer also sometimes creates confusion when dendritic cells and all. So web dreamer clearly gives a clear picture, one tier system or one generation, second tier, second generation, third. So respected sir, it is a very good question. First, we have to completely synthesize and also to see its stability by TGA, thermal stability, by putting in pH, whether with pH structures stable or this degraded. So first we have to ensure that its structure is fully stable in all the mediums wherever you are using drug. And we have, after that, we have to take a particular ratio of the this dendimer as a carrier and the drug. And you have to take the solvent. We have conducted that, we have taken volatile solvents, sir. Dendimer plus your drug, silibinine or other methotrexate drug in a ratio, and we have taken this acetone and then encapsulated. Once we encapsulated, we kept measuring its the transporting properties. Yes, it is going, it is going. So once it was all its cavities as per their ability to measure this, to develop. So the drug was encapsulated. The drug was encapsulated, and then we have slightly rota vapor, evaporated the solvent. So this was the overall picture, Sarji.
Okay, sir. Thank you, sir. Thank you so much, sir.
Sir, one more, Arijit Roy, sir, is asking a question. He is asking, can we calculate blood sample surface properties from service meter?
Actually, your voice of your from your side is very, I don't know why, low.
Sir, he is asking, Arijit Roy is asking whether we can calculate the blood sample surface properties from service meter.
Which sample? Blood sample?
Blood sample.
Sir, the question is in the chat box also. Question is there in the chat box.
Yes. Excellently. There's no issue because, yes, you are very right. Actually, if with time your blood is not clotted and you have adding certain things, so at any temperature, you can keep service meter at any temperature, at low temperature, high temperature. So whichever temperature your blood is not, you can take serum or blood also, there's no issue. So you can easily measure, honorable madam, no issue at all.
Sir, what should be the magnitude of zeta potential in these monodispersions in frequency when we are calculating?
Zeta potential and frequency relationship.
Yeah. What should be the magnitude? And
yes, I am telling you. See, ultimately, frequency means if it is higher frequency, as I have been telling you, monodispersion. When it is monodispersed, then only surface charges are available. If it is coagulation, then surface charge will not be available. So zeta potential, that's why Brownian motion. When you determine the DLS, in DLS, why Brownian motion? Because the monodispersed molecule have high kinetic energy. So because of the constituents are different. You may ask also this question, why does it Brownian? Because molecule does not have only helium. There are other functional groups. So their electronic configuration is different. So their spontaneity is different. So definitely, if frequency is higher, molecular monodispersion, then your residual charges, they are not used by another drug molecule. They are open. So that time prominent, not only this zeta potential, but remarkable monodispersion for PDI index. That will be also almost 1. So that is the point.
Okay.
Thank you very much. Very good question.
Thank you, sir. Sir, can we conclude now? Are there any questions? I will see. So there are no questions. We can conclude, sir.
Thank you. Thank you.
Okay, ma'am.
Very excellent
Thank you,
suggestion.
sir. Thank you, madam. There are few instructions for the participants. All participants are requested to fill the feedback cum attendance form for all 3 sessions and also requested to solve the quiz in a given time period. On behalf of coordinator, I declare today's sessions are over and we will meet tomorrow at 10:30 a.m. Please join 10 minutes before to avoid any technical glitch. Till then, stay healthy, stay safe, and bye-bye. Thank you.
Thank you, sir. Thank you, sir. Madam, I have already sent slides to you.
Yes, yes, sir. Yes.
So
sir.
you can widely circulate.
Yeah. Thank
And
you.
you have recorded this lecture.
Yes, sir. It is on
You
YouTube.
will put on your website, university website.
It is on YouTube.
It is live on YouTube.
It is
sir.
live on YouTube, sir.
Excellent, madam. Can you send the link to me?
Yes, surely.
Excellent, excellent. And Rajendra ji,
Yes, sir.
have I fulfilled your expectation or no?
Yes, sir. Absolutely, sir.